everyone, and welcome to our webinar on measurement uncertainty and advanced verification of the ASL 5000. Today's panel will be our Calibration and Service Manager, Anthony Rocco, and our Director of Engineering, Michael Bales. My name is Liz, and I will be your moderator today. Just a few housekeeping rules before we get started. During today's webinar, we will learn about measurement uncertainty, ASL 5000 ISO 17025 calibration certificate, and ASL 5000 advanced verification process. With that, I'm going to turn it over to our Calibration and Service Manager, Anthony Rocco.
Hello, everyone. As Liz introduced me, I'm Anthony Rocco. I'm the Calibration and Service Manager at IngMar Medical. I've worked for IngMar Medical for 14 years, and specifically in the calibration lab for the last 3 years. We have been accredited since December 2016. And today I'm going to give, for my part of the webinar, I'm going to give a simple overview of what measurement uncertainty is and how that measurement uncertainty applies to our ISO 17025 calibration certificate. A simple explanation of measurement uncertainty is it is the doubt that exists about the result of any measurement. You might think that well-made rulers, clocks, and thermometers should be trustworthy and give the right answers. But for every measurement, even the most careful, there is always a margin of doubt. In everyday speech, this might be expressed as give or take. An example would be, if we are looking at the clock right now I have 2:05 Eastern Standard Time, but most of you will have 2:05 with a different second-hand reading than I do. The way we calculate this difference between these measurements is by collecting all the data at the same time and inserting that data into a measurement uncertainty budget. That simply leads to the question, what is a measurement uncertainty budget? A measurement uncertainty budget is similar to cooking in a way. Say the end goal of a kitchen is to make 10 of the same pies from the same recipe. We would use the recipe with the same instructions, the same ingredients, and cook them in the same way in the same oven. Even if you did everything correctly, those 10 pies would look the same, but there would be a small amount of difference between them. We can figure out a statistical figure of that difference if we recorded the process and data in a measurement uncertainty budget. Next, I'm going to show you an example of a measurement uncertainty budget from our own scope of accreditation. Here's what a measurement uncertainty budget looks like. Here is a measurement uncertainty budget for our vacuum pressure meter, where we are testing 20 centimeters of water. Here are the ingredients we use to make up the measurement uncertainty budget, shown here as contributors. Here's us recording the test results of 6 ASL 5000s running the same test 11 times on each ASL. As you can see, we use a wide range of ASL 5000s, ranging from older to newer, to give us a broader scope of the measurement. So after we enter all those factors, the ingredients, we have a statistical figure of the doubt represented as expanded uncertainty that equals 0.1 centimeters of water for our measurement of 20 centimeters of water. Here's the back of our calibration certificate, our ISO 17025 calibration certificate. As you can see, the uncertainty listed on the calibration certificate for the test result of 20 centimeters of water comes directly from our measurement uncertainty budget from the previous slide. And every uncertainty listed on our calibration certificate has measurement uncertainty budget that is approved by our accreditation provider before we could issue it to the certificate that is provided to the customer. IngMar Medical is accredited by the American Association for Laboratory Accreditation, A2LA, to the ISO 17025-2005 standard. In January of 2019, we will be audited to the 2017 version of the standard, where we are looking to expand our scope of capabilities. Our current scope of accreditation can be found both at ingmarmedical.com and a2la.org. Our certificate number is 4172.01. Now I'd like to hand off to Michael Bales, our Director of Engineering, where he will give an explanation of the advanced verification of the ASL 5000.
Thank you, Anthony. My name is Michael Bales, and I am the Director of Engineering at IngMar Medical. The second half of this webinar will focus on the advanced verification process here at IngMar. Every ASL built at IngMar Medical undergoes a standard calibration before being shipped to the customer. We recommend annual recalibrations specifically to our developers and researchers, but also to our educators as well. The advanced verification is a means to further characterize unique ASLs for research and development purposes. On the slide in front of you, you can see all of the different tests we perform in addition to the standard calibration when we perform an advanced verification. The array of additional tests that we run range from pressure sensing and evaluation of resistance, compliance, and volume, to name a few. Pictured here is our 17025 accredited calibration laboratory. All of our tests are conducted in this lab. We monitor the environmental conditions and we secure our NIST traceable calibration standards. For those of you who don't know, NIST traceability is the means by which we have our accredited certificates. So all of our standards are evaluated and verified before we use them to test on the ASL. So now I'm going to go through each of the different tests that we perform with a high-level explanation of how the test works. So the first test we call pressure sensor verification, temperature drift uncertainty. The importance of this test is to assure the temperature fluctuations within our embedded system do not affect the outputs from our pressure sensors. The cylinder pressure sensor is the single most important device in the ASL as it measures the airway pressure to start the breathing algorithm. The next test we call pressure sensor verification, pressure zero calibration statistics. This test verifies that the analog noise in the sensor is minimized when the system is breathing. We want to assure zero pressure is maintained and constant at the end of each breath. The next test we perform is called volume verification with a calibrated syringe. For the volume verification, we use 3 NIST traceable syringes. Our testing consists of setting up a passive patient model and providing 5 strokes from each syringe to verify the volume accuracy of the lung. As you can see on the slide, we use 3 syringes for the standard ASL and the larger ASL XL. And when a preemie adapter is used, we use 2 syringes. The next test we perform is called compliance verification. The ASL operating range of compliance is 0.5 to 250 milliliters per centimeter of water. Using the same calibration syringes we use for the volume verification, we evaluate the pressure feedback and use this to determine the compliance. Please note that the compressible gas that's inside the cylinder or the lung is also considered in this evaluation. The standard values, the values that are measured for the standard and XL ASL are shown below, which is 50, 10, and 1 milliliter per centimeter of water. In the preemie adapter, we measure it down to from 3 and 0.5 milliliters per centimeter of water. I combined the next 3 tests into a single slide because we use the same evaluation methodology to verify these tests. The 3 tests are spontaneous breathing verification, pump mode verification, and peak flow verification. Each test evaluates a model with a resistance, a compliance, and an effort. And that model is then compared to the physical position of our piston, which is measured through an optical encoder. In the end, we want to minimize that amount of error between the model and the actual data. The last test that we perform is called resistance verification. We evaluate our resistance based on the RC time constant equation. To determine this, we run a patient model with a set resistance value. The software feeds back the maximum volume for each excursion. We then solve for resistance based on evaluating the volume at 63.2% of its max using the equation resistance is equal to the time constant divided by compliance. The resistance range of the ASL 5000 is from 3 to 500 centimeters of water per liter per second. The evaluated resistance resistances that we measure are R5, 20, 50, 200, and 500 during this test. Once all of these tests are complete, we provide a detailed report with all of the testing and data analysis. At this point, I'll hand it back over to Liz for any questions you may have about either measurement uncertainty or advanced verification process. And thank you very much.
Okay, thank you to our panel today, Anthony and Michael, and they are still in the room with me to answer your questions. So if you have any questions, we encourage you to ask them in the Q&A panel of Zoom. It looks like we do have some questions starting to flow in, so I will begin to answer them. Our first question comes from Joseph. Joseph asks, how do you measure flow in the ASL?
It's a great question. The ASL 5000 actually does not have a flow sensor, whereas it has a pressure sensor. The reason is because flow sensors tend to experience drift, and therefore they have to be recalibrated much more often. In this case with the ASL, because we have an optical encoder which very accurately provides us with volume, we send the raw volume data to the software, which is our main ASL 5000 software, and we run a derivative calculation against that volume to determine our flow.
Great. Our next question is from Heather. Heather asks, why is flow not on your calibration certificate?
Hello, Heather. The reason flow is not on our calibration certificate and is not because it is not yet on our scope of capabilities accredited by A2LA. We're looking in January of 2019 to add a flow standard to our scope of capabilities, but as of right now, that is not available. As Michael just explained, flow is calculated by equation of motion as of right now. But IngMar Medical is actively searching for a standard to match against the ASL 5000 to be as accurate as possible.
Okay, it looks like we have another question here. Evan asks, what does being an ISO 17025 accredited lab really mean to us, the customer?
Hello, Evan. Being an ISO 17025 accredited lab or having an ISO 17025 accredited lab simply means that our numbers are audited yearly by a third party. IngMar Medical could issue a calibration certificate and issue that to the customer. But to know that those numbers are correct, there's oversight in that in 17025 accreditation bodies. So ISO say what you do what you say. If we say our numbers are correct, so does a third party accreditation body. So that is what it means to you. It's not just us saying it, it's actually IngMar Medical and A2LA saying it.
Great questions so far, so everyone keep them coming. Our next question is, why can't you use a flow pump to evaluate resistance?
Thank you for the question. This is Michael. The easiest way to answer it is the amount of space available in an ASL's piston does not allow enough time for a flow to evaluate to give us an accurate result. However, we are working on a process by which we use an ASL in a flow pump or volume pump mode to deliver a constant flow to a secondary ASL, which would be the one under test. By this, we can get enough of a flow rate and we can automate that process whereby we could receive accurate linear resistance results. This is a work in progress and we hope to have something in the near future.
Okay, another question coming in from Janine. Janine asks, do you have plans to expand on the evaluation ranges for resistance, compliance, volume, etc.?
Yes, we're always looking to extend the capabilities of our validation and verification process. We want our developers and our researchers to really know that the ASL that they're using has they have the most data that's possible. Right now, it's more or less static tests in terms of individual values, but as I mentioned before, if we were to add a second ASL as our, let's call it a calibrated piston pump, then we could use that to evaluate virtually any resistance and compliance values as requested from a customer.
All right, great questions. Next question is from Gerald. Gerald says, glad to hear and see that IngMar has not only considered uncertainties of measurement, but also the unbroken chain of traceability for its calibrations. The purpose of the 17025 accreditation. Do these processes also apply to other test lungs you certify?
As of right now, we offer a ISO 17025 calibration certificate only for the ASL 5000. We look in the future, whenever I was talking about expanding our scope of capabilities, IngMar Medical being a young lab, we look to have ISO 17025 calibration certificates for all of our products. But we figured since we are such a young lab, we will simply start with our flagship product, the ASL 5000. But yes, in the future, we do hope to expand that to our other products as well.
Okay, our next question. I see a note on my certificate that says uncertainties marked not applicable are not covered by your scope of accreditation. Why is that?
If there is an uncertainty marked NA, that means that that is simply a test, not a measurement. So on the back of our calibration certificate, you might see an NA for a leak test. A leak test is simply just a test. There's no measurement involved. There is a measurement involved there, but it is a measurement for hardware, not for reporting data, if that makes sense. There's also for O2 tank, for our O2 sensor. So why there is not a measurement uncertainty budget for our O2 sensor is because the way that we calibrate our O2 sensors are by an oxygen tank that holds 100% of oxygen. But even though it's 100% of oxygen, each tank is different. So the tank we have right now is 99.7% pure oxygen. So as soon as we've received another tank, we would have to have a new measurement uncertainty budget for that tank. And as we all know, tank's empty. So instead of doing that, we just give you simply ambient, which is 20.9, the air we're breathing hopefully right now, and then the tank that we received. So we give you the low and the high when we calibrate our oxygen sensors. But the reason we do that is just because of the turnover in tanks, in the amount of work it would take to create a budget for each time we got a new tank.
Gerald asks, what are the implications to the patient for their risk of injury when connected to a ventilator that has been calibrated using the ASL 5000?
That's an interesting question, Gerald. The ASL 5000 itself as a testing device is not FDA regulated. So I guess I don't know if ventilator companies use the ASL to calibrate the ventilators before going to touch a patient. I know that they use it extensively for testing their development products. I'll be honest, I'm unaware if they use it on the manufacturing side at this time. But as I said, we don't have FDA traceability or approvals with our product because we do not touch the patient.
Thank you to everyone for your time and your questions today. If you have any questions that you think of offline, please feel free to reach out. You can contact sales@ingmarmed.com. As always, a recording of this webinar will be made available to you via email, and it will be posted to our website within the next week. You can also access the recordings for any of our previous webinars under the training section of our website. And we will also be distributing a survey via email as well. So please let us know how we can provide you the best possible webinar experiences going forward, including suggestions for topics you would like us to cover. Thank you again so much for attending and have a wonderful weekend.